Welcome once again to our YouTube channel. Thanks for subscribing to our channel. We really appreciate you for all that you've done. Today we want to look at the WAEC 2023 Agric Science Practical Specimens. The WAEC 2023 Agric Science Practical Specimen. So we'll be listing the specimens, after which we will quickly have a rundown of some of the possible questions that you can come across in the WAEC exam itself. So let us quickly list the specimens out. We have specimen A. Specimen A is Earthworm. Specimen A is Earthworm. We have specimen B to be Termite. Specimen B is Termite. Specimen C is the Lumi Soil. Lumi Soil. That is our specimen C. And our specimen D is Sandy Soil. We'll quickly list the specimens so we will get ourselves familiarized with them. Our specimen E is water trough. Water trough. That is what our specimen E is, while our specimen F is the feeding trough. The feeding trough. We have specimen G to be the egg candler. Egg candler. That is what our specimen G is. And specimen H is scoop net. Scoop net. Specimen I happens to be sugar cane. Sugar cane is our specimen I. And then we have specimen J to be the pineapple fruit. Pineapple fruit. And then specimen K is ginger. Specimen K is ginger. We have specimen L to be honey. Specimen L is honey. Then we have specimen M to be sawdust. Sawdust. Specimen N is wood shavings. The wood shaving is our specimen N. Wood shavings. Specimen O now. Specimen O. Specimen O is the electric bulb. Electric bulb is our specimen O. Then we have specimen P to be the kerosene lamp. Kerosene lamp. That is our specimen P. And then we have specimen Q to be charcoal pot. That happens to be the last specimen for the Agric list of specimens for year 2023 WAEC. So we have listed them. These are the list of specimens that we'll be talking about. A is Earthworm, B Termite, C Lumi Soil, D Sandy Soil, E is water trough, F feeding trough, G egg candler, H is scoop net, I is sugarcane, J is pineapple fruit, K is ginger, L honey, M sawdust, N is wood shavings, O electric bulb, P kerosene lamp, and Q is the charcoal pot. So we'll quickly be looking at each of them one after the other. We'll possibly give some pictures to clearly show what we are talking about to aid the teaching. So let us go straight to taking the first specimen. The first specimen is the earthworm. Specimen A. Specimen A is the earthworm. So that is where we are going to kick it up from. The earthworm. So let us see what we have for the earthworm. Now the earthworm is, let me start with saying it is a macro decomposer. It is a macronutrient decomposer. It helps to provide nutrients to the soil. So first, let me tell us what its botanical name is, or its scientific name rather. It is called the Lumbricus terrestris. It is called Lumbricus terrestris. Lumbricus terrestris. That is its scientific name, Lumbricus terrestris. Now, it is a terrestrial organism. That is what that is telling us. It is a terrestrial organism. A terrestrial organism. meaning it survives on land, though its own niche is under the soil. It burrows into the soil, that is where it is usually found, and then it possesses segmented bodies. Yes, possession of segmented body. Possession of segmented body. Now, if you look at the picture, like what I will be showing you here, this picture here is telling us that it has lines cutting across its body parts. You can see it. So those are the things that make or that show its segments, the segments of the body of the earthworm. Now, we also can say that they are, like I said, that they are decomposers. So they feed on decaying roots and leaves. They feed on decaying roots and leaves. Yes, that is what they feed on. They are agricultural aiders. They aid agricultural processes because they burrow into the soil. So they help in agricultural processes. So like I said, that they feed on decaying roots and leaves. Those are not the only things they feed on. They also feed on nematodes. They feed on nematodes. They feed on protozoans. So those are the things that you have the earthworm feeding on. So averagely, they are hermaphrodites, meaning they are hermaphrodites. The hermaphrodites. So they are actually possessing the two gamete cells of living things. That's the male and the female gamete cells. So they can actually reproduce on their own. So we can also say that they live, yes, I said that earlier on, they live in the soil. Now they decompose organic materials, and they can also be fed upon by birds, snakes, and the rest of those. Now, an average earthworm can live up to about between 3 to 5 years or 8 years thereabouts. So we have that is how they live their life. So the characteristics now is that they have long cylindrical and segmented bodies, possession of segmented and cylindrical bodies, so that is one of the characteristics. They also have hydrostatic skeleton. Yes, that is another very important one that we need to know. Hydrostatic skeleton. The type of skeleton they have is not exoskeleton, nor is it endoskeleton. Theirs is hydrostatic, meaning it is filled with fluid, and the fluid is pressured by the barriers of the body of the earthworm. So that makes it possible. It enhances their movement. Hydrostatic skeleton that aids movement, aids their movement and their structure. Their movement and their structure. So that is that. They also have the CNS and the PNS. Yes, they make function. Their body function with the aid of the CNS, the central nervous system, as well as the peripheral nervous system. They possess the CNS, possession of the CNS and the PNS. So we need to know that as well. Now, I've said it earlier on, they are hermaphrodites. So the kind of excretory organelle that they have is the nephridia. Excretory organelle for the earthworm is the nephridia. So that is their own excretory organelle, the nephridia. So quickly, let me give us some classifications of this particular earthworm. We know that the kingdom is Animalia, and so the class is, let me start from its phylum. If we have said that the kingdom Animalia, then the phylum is, we have it to be Annelida. The Annelida, they are annelids. The class now, they are Clitolata. So you may be and may not be asked all of this. The order now, order, it is the Lumbriculidae. Lumbriculidae. And then let me just go to the family. The family is Acanthodrita. And then we have the genus and the species. Genus as the Lumbricus, and species to be the Terrestris. So that is what makes up its scientific name. So that is what we have for the Earthworm. So if you look at this is a diagram showing its labeling. We have the head end, we have the mouth here, we have the head end, we have the mouth here. This part here is called the clitellum. This part here, all earthworms have them, it is called the clitellum. Then we can see all of the segmented body that it is being literally shown, and here we have the tail end. So that is what the diagram of the earthworm looks like. So let us go to the next specimen, which is specimen D, termite. Specimen D, that's it, termites. So termites are social insects. Termites are social insects. Social insects, and this is because they live in organized setting. They live in well-developed and organized setting. There are different castes. We have their castes. They have three major castes. We have the reproductives. The reproductives, which is made up of the king and the queen. These ones are responsible for reproduction. They are responsible for multiplying the caste. And then we have the soldiers. The soldiers are oftentimes the winged termites. And then we have the workers, which are the wingless termites. The workers. The soldiers usually have very, very strong mandible and the cephalothorax. So those are their characteristics, the characteristics of the termites. Now, the scientific name of the termites, we have it to be Isoptera. The scientific name is Isoptera. That is its scientific name. So they are herbivores. Termites are herbivores, meaning they feed majorly on plant materials, even though we know that they feed on some other substances like wood, like book, soil, and the rest of those. But majorly they are herbivores, plant eating organisms. Now, there is this particular thing that is called the nuptial or wedding flight. The nuptial or wedding flight. Now, this is done by the supposed or king and queen to be. They do that in preparation for nesting. They do it in preparation for nesting because when they go on this particular flight, you have the king and the queen attaching themselves together during the flight, and by the time they land on the ground, they lose their wings, and then they walk themselves into the establishment of their own colony. So that is how their caste is. So we have the caste system, which is an example of a polymorphism. Polymorphism is talking about the differences of some creatures in various forms. Differences of the same creature. Differences in appearance of the same creature, but in different forms, carrying out different functions. So now let us quickly look at their economic importance. The economic importance, because you could be asked that particular question. Economic importance of termites. Economic importance. Number one is that they maintain soil fertility. Yes, they maintain soil fertility because they help to burrow into the soil, thereby aiding the breakdown of dead trees. They aid the breakdown of dead trees, as well as permitting the movement of air and water in the soil. So they by breaking down dead trees. Number 2, we say that they improve soil drainage. Improve soil drainage. Yes, that is another function of the termites. Then the flying termites are very, very nutritious. The flying termites are eating. They are eating for the fats and protein that they contain. For fats and proteins. Yes, we have that. Then they are responsible for the destruction of wood. Yes, that is the commonest function that we know for them. They destruction of wood materials. Destruction of wood. So that is what they are commonly known for. They help to destroy wood. With wood that is used for construction. Also, we have the termitarium, which is their dwelling place, their abode. That is their niche, the termitarium, or their nest, which is used for production of the lawn tennis courts. It is used for the production of lawn tennis courts because of the elastic nature that it has. So it is used for the lawn tennis court. So these are few of the importance, the economic importance of the earthworm. Of the termites. Few economic importance of the termites. Now, let me quickly tell us that termites, they have incomplete metamorphosis. Incomplete metamorphosis. They have incomplete metamorphosis because they go from egg they go to nymph, and from nymph they go to adult. That is their life cycle, from egg to nymph, and from nymph they go to adult. It is this adult stage that we now have them differentiating into the 3 castes, which is the reproductives, the soldiers, and the workers. So this is what the picture of the termite looks like. You can see the picture of the termite here. You can see the head. So this is an example of a soldier. You can see it having the big mandible and the piercing mouth part. So it is very, very good at biting and chewing. So this is an example of a termite. So we'll be going to the next specimen now. The next specimen, which is we have the next, okay, let me see. We have the next specimen. The next specimen is going to be our specimen C. Specimen C. Specimen C, which is the Lumi Soil. The Lumi Soil is our specimen C. So what does the Lumi Soil have that we need to talk about? First and foremost, let me talk about the composition. The Lumi Soil is made of the sand, silt, and clay composition. We have sand to be 40%, sand 40%. We have silt also to be 40%, and lastly we have the clay to be 20%. So this is the composition of the Lumi soil. It is agriculturally very, very viable, agriculturally good. It is agriculturally good because of its high humus content. Because it contains humus. It contains humus. Now this humus has an active ingredient in it called the humic acid. There is what we call the humic acid in the humus, so it is agriculturally very, very good. Now, we said it is agriculturally good because it has more nutrients and moisture than the sandy soil. It has more nutrients and moisture than the sandy soil. Yes, that is one of the factors, because it has more nutrients and moisture than sandy soil. Very soon we'll be looking at the sandy soil as well, because we have to relate them to one another. Now, this particular soil helps for anchorage to the plant, helps to anchor plants, preventing them from falling, to anchor plants from their roots, or with their roots, so that prevents them from falling. Then it is better drained than the clay and silt. It is better drained because the clay soil does not permit water to drain out of it, unlike the loamy soil, which is better drained than the clay and silt. That's another class of the loamy, another class of the soil types. So it improves the soil texture. It improves the texture of the soil. So those are the characteristics of the loamy soil. Now let us quickly look. I said it improves, or it has improved soil texture. Improved soil texture. So these are the characteristics of the loamy soil. It said it is the best for planting practices. So the specimen D now, specimen D, which is the sandy soil. We have that to be another class of the soil types. So the sandy soil has high porosity because it permits almost all the water in it out of the soil type. High porosity, as well as having the smallest fine particles. The texture now, it has the smallest or fine particles of the soil grains, fine particles of weathering rock. That is what that particular soil type has. It is very, very poor for agricultural practices. Poorest for agricultural practices because it does not permit the plant, the soil to have access. It does not permit the plant to have access to nutrients in the soil because it has drained out all the nutrients in the soil, and that is because of its nutritional value. Because of its low nutritional value or soil fertility. So these are some of the reasons why we say that this particular soil type is not good. So you could be asked to give an experiment to show that sandy soil is more draining, more porous than loamy soil. This is how you go with that experiment. Let's assume you have two soil types. You have soil type A and soil type B, and you are given 20 grams of A, and you're given 20 grams of B too. So this is what you do. You get a setup which is going to be you have a beaker, in which you will have a funnel. Now in the funnel, at this place here, you try to drop cotton wool here. to prevent your soil type from falling into the funnel when you actually want to pour your soil into it. So this is how it is going to look. You have your beaker having its content. So we are going to designate our soil type A with these green dots. So our soil type A, you have poured your soil type into the funnel. So in the set of B now, you have similar structure. We have something similar to what you have just drawn. We have the beaker, then the funnel. We have the beaker and the funnel, and then inside it you have your cotton wool again. You have your cotton wool here. So if you have your cotton wool here, permit me to make this very, very neat. So we have this. Okay. We have our funnel looking like this, and so inside this we are putting some cotton wool to prevent our soil from running through it. And our second soil type B, we're designating it with these blue particles, these blue shadings. So after which you are going to run water into it. So you are adding water. Let's assume you are given a liter of water, that is 100 cl of water plus 100 cl H2O. The same thing for this one here, plus 100 cl H2O. So by the time you add your water into it, you found out that the water that got drained into this place here, you have your water that got drained into soil type A, and here you have your water that got drained into soil type B. Remember, you have added the same quantity of water into the same measurement of beaker, the same beaker measurement. So after which, after the setup, after the experiment, you found out that the amount of water that was collected in setup A is less, as let's say we collected 20 cl of water in the beaker of A, and then in the beaker of B we collected, let's say, 60 cl of water. So that is telling us that in A we have 100 cl of water that has gone in, giving out 20 cl. That means this one has actually held on to 80 centiliter of water. On the other hand, the B here, the B also took in 100 cl, and you added the water, and then it drained out 60 cl, telling you that 40 cl is what you got out of it. 40 cl is what the soil has held on to. So this is telling us that you find out that the one that is most porous, the one that has permitted more amount of water to go out of it, is the B. A has actually held on to about 80% of the water, while B held on only to 40% of the water, allowing 60% to drain off. So that is the experimental setup showing the kind of draining or porosity that we have in this particular experiment. So this is what the Lumi soil looks like. You can see it having, because it has water in it, it has some moisture in it, you can see some of the soil particles clogging together. So that is how the Lumi soil looks, because it has high content of humus in it. And if we look at this, we will be seeing the sandy soil. If you look at this, okay, if you look this way, we'll be seeing the sandy soil. This is an example of the sandy soil. So you can see the difference between them. So this is how loamy soil looks, and that is the sandy soil. So we will look at the next specimen now. So the next specimen we'll be having now is our specimen E. Specimen E. Specimen E, which happens to be the water trough. Water trough. Now, what is the water trough and what is it used for? A water trough is an agricultural feeder, or we use it in giving water to the animals, to farm animals. It is used to give water to farm animals. That is what the water trough is mainly used for. We have them in different shapes. We have some of them, or the common ones, to the box-like. They are usually found in box-like shape. They are man-made. And they are actually made from steel. They are man-made from materials like steel. We have some of them made from concrete. We have some of them made from plastics. So these are the materials that are used in making this particular thing that we're talking about. So they are used for feeding animals. It could be livestock or poultry animals. Livestock or poultry. So whichever one that you are using is what they are used for. So this is an example of the specimen we're talking about. This is what the specimen we're talking about is. You can see this is an example of a water trough. The water will be found in this container in the middle here. So it permits the animals access. It gives the animals access to actually having a drink of water. So the next specimen we want to look at now is the specimen. We have the specimen F. Specimen F to be the feeding trough. The feeding trough. Now the feeding trough is somewhat like the water trough. The only difference there is that the feeding trough is for feed, while the water trough is for water, like the name implies. This is used to house or contain animal feeds. To house or contain animal feeds. That is what it is used for. So any farmer that is actually an animal farmer will always need a feeding trough. Now they come in different forms. Some of them are wood, made from wood. We have some of them to be wood. Some of them are steel. We have some of them to be concrete. Some of them as well are plastics in nature. So those are their functions. So now this is it. They help functions now, or advantages. Functions or advantages. One, they keep the passage clean and clear. Keep the passage clean and clear, because you will not be having the feed littering the floor. They keep food animals clean and within reach. Keep food or feed of animals clean and within reach. It will be easily accessible. To be easily accessible for the animals. They are usually tough and durable products. Yes, so they are not easily destroyed by the animals. Tough and durable. They are not easily destroyed by the animals. And then the ones that are steel, they are actually not rusty. So they are rust and corrosion resistant. Rust and corrosion resistant. Yes, they are actually rust and corrosion resistant. So we can have them for the ruminants as well as the poultry. Now we have the different types. Now. The types, we can have the hanging trough. We can have the hay feeders. As well as the last one, which is the mineral feeders. Well, let me not say the last one, but at least we have these three to be the commonest. So we can have some other example. So you can see this example here. Look at this diagram here. You can see the animals eating from this thing here. This thing has a metal or a steel stand, and then this blue part here is made from tank, so it helps to contain their feed. This is another example that we can look at. You can see this one here. Let's see. We can also have this one here as another example of the feed. This is another example of the feeding trough. So those are the examples of the feeding trough. So let us move to the next specimen now, which is our specimen G. Specimen G, that is our egg candler. The egg candler. So what is an egg candler and what is it used for? The egg candler is actually an instrument that helps to detect if a particular egg is viable. It is used to detect if the particular egg is viable. It is used to observe the growth. It is used to observe growth. To observe the growth and development of an egg, particularly during incubation. So yes, they want to know where of the egg or the embryo that is inside the egg. So they want to know if that particular egg is actually incubating properly. The device is used for testing the egg, particularly the developing incubation, to determine if they are still viable. Yes, to determine if they are viable. That is its function, to determine if they are viable. And now we have different types of them. We have the old candler used. We have different types of candler, but the old type of candler is the use of candle, which is implanted into a box that is well shaded. Then it will have a hole at the top of it that the egg can stay without falling through into the box. So it will permit light to go into the bulb. That is what you're actually seeing. It will permit light to go into the bulb, preventing it from falling through. So this is an example of the candler that we're talking about. You can see this is a modern candler, and so it has the egg standing on it. So when they switch it on, this is what I'm talking about, the modern candler. When they switch it on here, when they power it on here, the egg on it will have light shown on it, such that we'll be having some of this that we have in this box here as what the image of the egg will be. So it helps to know if the egg is actually developing or not. It helps to know if the egg is developing or not. You can see this one as well. You can see this as well. When we look here, we see this particular specimen too. This is another egg candler having multiple eggs on it. So it shines light onto the egg, so it will be able to give you the growth rate of the eggs. So that is what the candler is. Now let us pick our next specimen. Our next specimen is going to be the specimen H. Specimen H is our next specimen. Specimen H. And what is the specimen H? It is a scoop net. Scoop net is our next specimen. Yes, so what is a scoop net and what does it do? A scoop net is a fishing tool, a fishing gear. It is used to take out fish from the lower ends of a pond. It is used to take out fish from the lower end of a pond. A fishing net. On a long handle. Used to reach. It is used to reach the base or the bottom. The base or the bottom of a river or the other shallow waters. Now, it is depth into the water and rapidly taken out to allow the fish pick up some of the to allow the net to pick up some of the fishes. So it is a traditional fishing gear. Harvesting a fish using this particular gear requires you to bury the net deep into the water and rapidly bring it out again. That is how it is being used. Used rapidly by burying the net. By burying the net into the water, burying the net into the water and bringing it out, bringing it up and out in a quick succession. So that is how it is being used, in a quick succession. This is an example of what the fishing net, the scoop net rather, looks like. This is how it is. Usually the handle is longer than this, and then it has a rope. So you dip this part here. The handle is longer than this, and it has a rope. So you dip this net into the water, and you quickly use it to pick up the fish sample. So the next specimen we want to look at is going to be the specimen I. Specimen I, which is sugarcane. Sugarcane, that is our next specimen. Now it has its botanical name. The botanical name for sugarcane, we have it to be, we call it the Saccharum officinarum. Saccharum we call it the Saccharum officinari. We call it the Saccharum officinari. That is what it is being called. So it is a perennial grass. This particular plant, the sugarcane, is a perennial grass. Yes, it has a very, very long duration of lifespan. It's a perennial grass, and it is a raw material for sugar and ethanol. Raw material for sugar and ethanol. Raw material for sugar and ethanol, and it has an average of 2 to 6 meters tall. It is a 2 to 6 meter tall plant, usually found to be stout jointed. It has stout, okay, with stout jointed fibrous stalks. Stout jointed fibrous stalks that are rich in sucrose. Yes, that is about the sugar cane. Yes, they are very, very rich in sucrose. They contain energy. they contains energy, like we have, okay, contains energy, fats, sugar, vitamin C, yes, and it is an active antioxidant. It is an antioxidant that helps to remove free radicals. Antioxidant, yes, it is an active antioxidant that removes or fights free radicals. It removes or fights free radicals that attack the body cells and organs. Yes, so that is, it combats free radicals or molecules that cause damage to body cells. They are cultivated for their juice. Cultivated, yes, the sugarcane is cultivated for its juice. That is the major reason why the sugarcane is cultivated, and the juice is used in sugar production. Is used in sugar production, and they are best grown in irrigated lands. Best grown in irrigated lands. Irrigated lands. So that is what sugarcane is. So that is what sugarcane is. So they are planted in irrigated land. So this is an example of what sugarcane is like. You can see the stalk here. You can see the stalk with short. You can see that that's short, jointed. You can see the joints here now. You can see the joints. You can see the joints here. So they have short, jointed, fibrous roots, and they are perennial grasses. So that is about the specimen I. And then we are moving to specimen J. Specimen J. Specimen J. So specimen J is a pineapple fruit. Pineapple fruit. That is our specimen J. Our specimen J is pineapple fruit. So we need to know what pineapple fruit is. What pineapple fruit is. So let us quickly do this. Now we have just said that it is a fruit. Its botanical name, we have its botanical name to be the ananas comosus. Ananas comosus. If you notice that I am writing my botanical name, the first letter of the name, which is the A, the ananas, is in capital letter, while the C starting the second word here is in small letter. That is how botanical names or scientific names are being written. So ananas comosus, it is rich in vitamin C. Yes, rich in vitamin C. So it is also an active antioxidant. It aids digestion. It aids digestion. It enhances weight loss. Yes. They produce hormones. Yes, that is another function of it. It produces hormones in the body. It helps in the production of hormones in the body, and the particular hormone that it produces is called the bromelain, which is responsible for skin healing. Bromelain is the skin hormone that it produces for skin healing. Yes. Now they are found largely. They are large tropical fruits with spiky. Yes. Let me do this. They are large tropical fruits. Large tropical fruits. Large tropical fruits, largely grown. They have spiky thorns, spiky tough skin with spiky tough skin and with sweet inside. Now, one of the disadvantages of taking excess amount of pineapple is that it can cause nausea. Disadvantages now. Disadvantages of taking excess of this particular fruit. It can cause nausea. It can result to diarrhea, vomiting is another thing that can result from excess consumption of this particular fruit. It can cause abdominal pain. It can also result in heartburn. So these are few of the things that can result from excess consumption of this particular fruit. So we can see example of the fruit here. This is an example of what pineapple fruit looks like. You can see them. You can see all of the round spiky back that it has, and the back is very, very tough. Then it has this part as what it can that is the vegetative part of this particular fruit. The vegetative part is this part here that can be planted to have more of that particular fruit. So the next specimen we'll be talking about now is going to be the specimen K. Specimen K, which is the ginger. Now, ginger is a rhizome that has many nutritional and healing abilities. It is used by healers, majorly used in places like China, India, and the rest of those. Now, its botanical name is called the Zingiber officinale. It is called the Zingiber officinale. That is what it is called. It looks like turmeric. This is what the ginger looks like. So this is what the ginger looks like. We have it looking like this. It has its own plants. Let me show you how the plant looks. The plant looks like this. You can see these are the roots. The rhizome formed here. That is where you have the ginger itself, and this is the stem. This is how the stem looks. So we have different varieties of the ginger. It also looks like the turmeric. So let us quickly see some of the characteristics that we can talk about for this particular organism. We said it is a rhizome used for spice and used as spice, and then for its healing abilities. Is used as spice for its healing ability. It increases the serotonin and dopamine levels in the body. These are hormones that are needed, enzymes that are needed in the body. It increases the serotonin and dopamine levels in the body. Yes, they reduce inflammation. Yes, that is another function of the ginger, reduction of inflammation. So that is one of the healing abilities. It is good for anxiety, depression. It helps to alleviate anxiety. Depression. Yes, because in fact we have people who chew them ordinarily without using them in any meal. It also helps to alleviate dementia, forgetfulness, as well as the Alzheimer's diseases. We have the Alzheimer's diseases, or something called the PTSD, that is post-traumatic stress disorder. Post-traumatic, that is the meaning of the PTSD, stress disorder. PTSD, post-traumatic stress disorder. So ginger can help to alleviate all of this. It eases stomach pain as well. Eases stomach pain. It eases stomach pain, and then it eases or treats nausea and motion sickness. Treats nausea and motion sickness. So those are some of the things that this particular plant do. We have said earlier on, it is also an herbaceous perennial plant that prevents swine flu. Herbaceous perennial plant that prevents swine flu. Prevents swine flu. So we have talked about the ginger now. So this is its picture. You can see it here. So let us move to the next specimen now. The next specimen we'll be having is going to be the specimen L, which is honey. Specimen L. Specimen L, and that is honey. Specimen L is honey. So what is honey? I believe all of us know what honey is, so let us quickly talk about it, and then we talk about its nutritional or health implications. Now, honey is gotten from honeybees. Yes, that is where it is gotten from. From honey bees. When you actually go through their beehive, in their hive or comb, in their hive, that particular thing that they have found is called the hive or the comb. So it is thick, sweet fluid. The honey is a thick, sweet fluid that is gotten by the bees from plant nectars, produced by bees from plant nectars. That is where they get them from. So they are used as sweeteners in food. Used as sweeteners. Used as sweeteners in food, and they have anti-inflammatory. Yes, they are anti-inflammatory. They are also antioxidants and antibacterial. Antibacterial in nature. Antibacterial in nature. They are better for blood sugar. Yes, they are sweeteners, and then better for blood sugar. So somebody who is having diabetes can stop taking sugar and take this particular species, which is the specimen, which is honey. Yes, it also boosts immunity. It boosts the immunity of the body. The immunity. It boosts the body's immunity. So we have different ways through which you can test to know what the true honey is. One of the ways through which you can test to know the honey bee is by actually pouring the honey into a cup of water. If the honey mixes with your water, then it is not original honey. Another way is by putting a matchstick into the honey. If you put a matchstick into the honey and you try to strike it, you find out that it ignites. If it were to be a fake honey, the matchstick will become moist, and so it will be unable to ignite. Another method is by you pouring it in a particular spot. If it is being gathered by ants in no time, then it is not real honey. If it were to be real honey, ants will not gather it. And lastly, we have another one, which is you actually putting it into a freezer. Real honey doesn't freeze when you put it into a freezer. So those are few tests to know real honey. So we have this as example of the honey. This is an example of the honey, and we can see this is another example of the honey as well. We can see the honeycomb here. This is the bees in their net, in their hive. This is their hive. This here is what we refer to as their hive, and each of these things here, they are the bees. So they are in their hive having the production of honey done. So that is what the specimen L honey is about. So let us move to the next specimen now, so we have specimen M now to be the sawdust. Specimen M. So let's have it here. Specimen M, which is our sawdust. So that is what we want to look at quickly. So specimen M is gotten from the wood. We use the wood. It is the wood that is being cut and shaved to get specimen M. So we say it is a byproduct or a waste product of woodworking. Byproduct. It is a byproduct or the waste gotten from woodworks of woodwork. Now, this particular sawdust has its own use. It has its uses. Well, woodworking operations. We have some operations like sawing. Operations such as sawing, that's cutting of wood. We have milling and planking, milling and planing of wood. So each time we have to do all of this, we eventually have the production of the small chippings of wood. So it is composed of the small chippings, composed of the small chippings, of the small chippings of wood. So the sawdust rather, as we said, can be gotten from sawmills, wherever you have the cutting and the slicing of planks and wood. So it has some advantages. This particular specimen, the sawdust, it has some advantages. Advantages like, advantages now, or its uses, functions. So a few of them will be listed here. We have soaking up spills. It is used to soak up spills. Soak up spills. Wherever there is, let's assume we have oil or water spilling somewhere, you can just add the sawdust to it so it can soak up the spill. So after which you have to sweep it all up. Also, we have it to it is used as fire starter. It is used as a fire starter. It is because it is highly combustible, so it can be used in igniting fire. It also fills wood. It is also used in filling wood holes. So whenever you have a hole in a wood, you can use sawdust to fill up that hole. It is used in cleaning floors as well. It is a cleaner for the floor. So it is used in cleaning the floor. So we have those as example of the advantages of sawdust. Also, it can be used mixed with manure or the supplement. It can be used as feed for plants, mixed with manure for the plants to absorb them up. So those are the advantages that we have for the sawdust. So this is an example of what the sawdust look like. So we have this as an example of the sawdust. You can see this particular picture here. That is what the sawdust looks like. This is another example of what the sawdust looks like. You can see it with a collection of wood pieces there. So it is from the wood pieces when they are sawing the wood. That is where we have the production of the sawdust. Our next specimen is going to be the specimen N, which is wood shavings. Specimen N. Specimen N. Specimen N. So we said it is wood shavings. So there is a very fine difference between the specimen M and the specimen N. Sawdust and wood shavings, they are actually gotten from the same material, from wood. So why are they now different? Wood shaving is a base layer with thick covering of straw. Is a base layer with thick covering of straw. It is a waste obtained when wood is shaped or planed using a carpentry tool. It is popularly used as beddings in poultry. Yes, this particular specimen that we're talking about is not like the sawdust. The sawdust is dust particles, made of dust particles, but the wood shaving is not actually dust particles. It is in layers. So we said that it is a base layer with thick covering. A base layer with thick covering, of straw. So it is a waste that is obtained, when wood is shaped or planed. When wood is shaped or planed, that is when we obtain the wood shaving when wood is planed or shaped using a carpentry tool. Using a carpentry tool. So it is from the tool that we get this extraction of this particular material. It is popularly used as beddings in poultry. Popularly used as beddings in poultry. Even in some pens it is used in poultry. It is also used in some pens. It is used as beddings in poultry and in pens. So this is an example of what the wood shaving looks like. If you see this now, you see that it is not like this particular one here. It is not like this particular one. We have this. This is an example of wood shaving. So we can see example of wood shaving. Unlike this one here, that is sawdust. This is sawdust. You can see the dust particles from this one here. These are examples of sawdust. This one here, these are examples of sawdust. But this one is not. This one here is not sawdust. It's not sawdust. This is wood shaving. So that is that about wood shaving. So the next specimen we have now before us, that's specimen O. Specimen O is electric bulb. Specimen O. Specimen O, that's electric bulb. That is our specimen O, electric bulb. So we want to look at what electric bulb is. Electric bulb actually gives light. It produces light. And for this particular purpose, we'll be looking at the type of light that it produces and then what it can be used for. It is electric bulb, like the name implies, it is gotten from electricity. The power behind it is electricity, powered by electricity. Electricity powered and so it is smokeless. It is smokeless. It doesn't produce or generate any smoke except in rare cases where the bulb is faulty. So it uses wire filaments to glow on application of electricity. Uses wire filaments to glow on application of electricity. So when power is run through it, when power is permitted to pass through it, when you run current into it, the wire filament starts to glow. So it produces light or luminosity. It produces light, or we say luminosity for the surrounding, and then heat that is used in poultry to keep birds warm, as well as heat in the poultry to keep the birds warm. So that is the major reason why we make use of electric bulb, particularly in the poultry. So we know that it is electrically powered and it is smokeless. It uses wire filaments to glow when electricity is allowed to run through it, and then it produces light as well as heat. It produces light for luminosity for us to be able to see, and then it also generates heat energy. The heat energy is what is used to produce or to generate heat, to give warmth for the birds in the poultry. So that is that about specimen O. Let us quickly see a picture showing the specimen O. So these are examples showing a bulb. This is an example of a bulb. You can see it. So it produces, this thing in the middle here is what we refer to as the wire filament. So it is that thing that glows, that gives out the luminosity, and then the filament gets heated up and it starts to radiate the heat to the surrounding. So this is an example of the filament. You can have this as well as example of a bulb. You can see it. This is another example of a bulb. So that is what we have for the specimen O. And then we have specimen P now to be kerosene lamp. Specimen P, which is kerosene lamp. That is our specimen P. So here we'll be talking about specimen P as its function. We're talking about its function. So one of the functions of specimen P is what the functions of specimen O is. We said that specimen O is used to generate heat and luminosity. So that is what the kerosene lamp is also doing. But it is powered differently. The kerosene lamp is powered using a particular fuel. The fuel it is using is kerosene. It uses kerosene. It uses kerosene as its primary fuel or as its fuel. Unlike the specimen O, which is electric bulb, which uses electricity to actually give out its own glow. So it uses this particular kerosene lamp uses kerosene as its own fuel. Sometimes it smokes. It gives out smokes. It smokes, particularly when you don't care very well for it. It has a wick or mantle. Possession of wick or mantle. This wick or mantle helps to protect the glass. It is protected by the glass or the glass chimney or globe. The wick or the mantle is what carries a thread-like substance that actually is soaked in the fuel, so it can give out its light. So it has a wick or mantle carrying the thread-like substance. The thread-like substance which is actually being lit. So it is this that is being protected by the glass chimney. It's protected by a glass chimney or the globe. So that is what helps to protect it. So this is what I am saying here. Alright, so if you look at the middle here, there is something in the middle here, somewhere around here. That thing is the chimney. Is the wick or the mantle. So it carries the thread that comes into this lower part of the lantern or the kerosene lamp. So that thing is what we actually put our flame to, so that it can start glowing. So it is covered by this outer appearance, which is the globe or the glass chimney. So that is what the kerosene lamp is about. Now, it is also used in providing warmth for poultry beds. It is also used in providing warmth for poultry beds. So we use it also like the specimen O is being used, like the electric bulb is being used. It also provides luminosity as well as heat for poultry beds. And lastly, we have the specimen Q. Specimen Q is the charcoal pot. So like we have been talking about generation of heat as well, this one also generates heat, though it doesn't generate as much luminosity as the electric bulb and the kerosene lamp does. So it generates heat as well. It is also used to generate heat, and the heat can also be used like others are being used in the poultry. Yes, it can also be used to provide heat for the poultry beds. So we said it is also used for the production or generation of heat. So that is the function of the charcoal pot. Though it is used extensively in other areas, like the charcoal pot can be used in domestic cooking, can be used for domestic cooking, also for domestic cooking in the kitchen, domestic cooking. So it can be used in boiling at home and the rest of those. So those are the functions of the specimen Q. So here is an example of what the specimen Q looks like. You can see this is an example of what specimen Q looks like. That is an example of a charcoal pot. This is another example of a charcoal pot. You can see it is in this place here that you have your charcoal, and then when you light it, it starts to burn, and then we have ashes falling down into this lower part. You can have our charcoal here. Our charcoal can be here, after which the burning brings out ashes under it. So that is what we have for our agricultural science practical. I believe going through this is going to help us a long way in our examination. Don't forget to like our page, share this page, subscribe to it, and give us your comments. We want to have your take on everything that you have heard so far. Thank you very much, and God bless.